Alright, the first separation technique we're going to talk about is distillation. And distillation is used to separate components from one another in a mixture. So in this case, this is our experimental lab setup. And we have in this flask, we have a mixture of ethanol, water, and blue food coloring. And underneath it is a hot plate that's going to be used to heat up and cause the water to boil, which will boil the solution. And then above that we have a Y tube, which is this thing. And connected to that's a thermometer just to read the temperature of the water is boiling. So as the hot plate heats up, the mixture will begin to boil. And we have water coming from this faucet that will help the vapor condense in here, which the ethanol will begin to go from this side tube over to there and condense in this little ball. And so that's where you see the liquid right there. Okay, so as for the day analysis / measurements taken in this lab, we will be dealing with temperature. And so you look at the original temperature before the mixture begins to boil. And so in this case, the original temperature is 19.8 degrees Celsius. And then also once all of the ethanol has condensed into the little ball right here, the temperature will reach a plateau. And so at that plateau, it is currently 76 degrees Celsius. And the ethanol is known as the distillate, and so that collects in this ball. And so the boiling point of the distillate, which is ethanol, is actually 78.37 degrees Celsius. So it's actually really close to the boiling point that we got at the plateau. And so once all the ethanol is done condensing, the temperature will continue to increase after that. The next separation technique we're going to talk about is chromatography. Chromatography separates components based on their affinity. And so chromatography involves a stationary phase and a mobile phase. The mobile phase consists of the components and the solvent, and the stationary phase is an absorbent that has intermolecular affinity for the solvent as well as individual components in the mixture. So in this case, the filter paper, which was a circle and we cut into a rectangle, is going to be used as the stationary phase. And so the mobile phases are these 6 components. And so we have copper, nickel, manganese, iron, cobalt, and an unknown solution. So what we're going to do first is we are going to use a spotting technique where you use capillary reaction. So you take one of these and then get some of the solution in there, and it takes it up in there by capillary reaction, and then you just dot it on there, and we would follow the same procedure for each one of the components. So once they have all been spotted, you will then dry them. You can use a hair dryer or just let it dry in the air, and then we'll go around and spot them again, the same process. And then once that is complete, you'll dry again, and then form a cylinder and staple it together. And then next you're going to take a beaker and fill just the bottom with a solution of acetone, HCl mixture. And then next you are going to place this on top, and then place a piece of paraffin over that, and just let it sit for like 8 minutes as the chromatography develops. Okay, so once you remove this from the chamber, you will see the chromatography spots, and you just mark those with a line or a circle them to know where they are. And then you place them in an ammonia chamber, which can be found in the laminar flow hood, and that'll darken the spots as well. Okay, and then so after that, once you remove the filter paper from the ammonia chamber, your spots should be much darker. And then we are going to do the spot technique again to use solutions that enhance the band positions at these various cations. And so we have 5 different additional solutions that you apply based on a table. You apply those to the certain cation which they correspond to, and once you do that, they will form darker colors like this. And then the unknown, you will typically see more than one band, so you will see the brown here, which corresponds to that, and there's blue one here, which corresponds to the cobalt. And so that's how you know that those are 2 of the components in the unknown solution. So after this, you will then, okay, so for the data analysis, you will take a ruler and measure the distance from this line to the middle of the spots of the bands. And then you will also measure from the pencil line all the way up to here to this line, which is the front line. So that's how high the acetone / HCl mixture was able to go up the filter paper once it was placed in the chamber. And so from this, you will then put the distance from the line to the center of the band over the distance from the line to the front. And this will give you the RF values for each transition metal ion. and then from that you'll be able to identify the transition metal ion present in the unknown. Okay, so the final separation technique we're going to talk about is filtration. An example of this would be if you had calcium hydroxide, which is a precipitate, and if you had that in a solution and you needed to separate that from the solution, you would just take a piece of filter paper and a funnel, and then you would place the funnel into the filter paper, like so, and then you would just face that into a beaker, and then just pour your beaker of precipitating solution into the funnel, and then the precipitate will all collect in the filter paper while the solution goes through to the beaker.